Hey everyone, I'm glad that you're here. We're going to talk about these math mountains. I'm going to actually share my screen, and then I have my surface today that I'm going to be using on my Jamboard to help me write just a little bit better. Okay, so here's what we know about math mountains. I want to show you just a little bit about the progression because it's been coming up a lot in my conversations with teachers, and we're not using them the way that they're really designed. And so let me take you here and show you just a little bit about what it looks like. So even if they're new to math expressions, this is pretty important information. We actually start in kindergarten and we start with understanding the partners of a number, but really it's about the total. So we'll do something like we have the group of 5, which is the big part of kindergarten's standards, and then we're going to use a break apart stick, which is just in kindergarten is a popsicle stick, a coffee stirrer, etc. And we're going to split this number. So I can move my break apart stick here and I could show kids, oh look, so this is 5 is the total, but we have the partners of 4 and 1. Or we could remove that break apart stick and we could say, but I could also move the break apart stick here and the total didn't change, but my partners changed. So now I have 2 and 3. So you can see that the break apart stick shows me my different partners. And one of the more important pieces is that students see that the total did not change. Okay, so it's not my total changing, it's just how I've rearranged that break apart stick. So that's a big understanding for kindergarten. So they start their year with this. Then they go to, well, can you see what we've been doing? If I were to draw lines like this, do you see how we're setting them up for the math mountain? And they didn't even really know it, but they'll have these little purple tiles, and they'll bring their purple tile 5 down, and then they'll build 5 with their counters, which are usually square tiles. And even just with the counters, we're setting them up for the math mountain. So when we see that in kindergarten, that's not by mistake, the way we have them pull down numbers and represent them. So keep that in mind, that I know we all like to have kind of our own way of doing things, but there's some things that we probably shouldn't be doing our own way, right? And this is something that's going to make that connection for kids. So then they take it to, now could we actually draw the math mountain, right? And instead of having to use the break apart stick, we're still going to talk about how we know that total is 5. But in kindergarten land, the numerals are abstract. In fact, every grade, numerals are abstract. And so we want students to really know, what does 5 mean, right? So they can say, well, I know this is 5. And I say, well, okay, put it behind your back, bring it back out. And they have to recount that. They're still learning that this is a number that has a quantity. So now we can make a little bit more abstract, but really what happens is we use these tiny tumblers. And that's what, if you haven't yet bought my book, that's what my book is about. It's about the little story of these tiny tumblers. But they have 5 because they know this is the same. They've been building those equal groups, 5 equals 5. But if I split this group, instead of doing a break apart, what if I just took some of them and I put them down the mountain? And I put these other side down this side of the mountain. So we're saying that 5 is the same as 2 and 3. And then we represent it with the abstract symbol, which is 2 and 3. But if those tiny tumblers went back up every day, back to their house, and the total is still 5, could they go down the mountain differently? And of course the answer is yes. So this matters even if you're teaching 6th grade, because what we're seeing is we're seeing students that don't really know how the math mountain works, and then it's not really a tool. It's not an asset if they don't know how it works. Okay, so then we get to 1st grade, and 1st grade still uses the break apart stick, and then they really focus on that math mountain. So the math mountain is a model for breaking apart numbers. But the only way this break apart works, and which is why actually it's called the math mountain, kindergarten, 1st, 2nd, 3rd, and then in 4th grade we change the name. And we don't actually call it math mountain anymore. We make it more sophisticated and we call it a break apart model, because that's what it is. It's a break apart model. But if you mention 4th and 5th, 6th grade teachers the math mountain, that's what your kids are going to call it, which is totally fine. It doesn't really matter. So here's the break apart model, and it's this idea that any number now that I can put up there, I can break it apart into 2 different pieces. And if I know one piece, then I can count on to find the other one. I can do my tiny tumblers, like if this was 7 over here, I may not need to draw the 7, but I may need to say 13, 14, and come up with the other partner. So students start to learn really quickly that a math mountain is really where we could subtract here or we add here. I'm either going to put these 2 together to get my total, or I'm going to take this and subtract one of the partners to get to the other total, or I take this total and I subtract one of the partners to get here. So it really is, let's just say this was 8 here. Okay, so if I did 14 minus 8, they would say it's 6 because they also know that 8 plus 6 equals 14. It's that inverse operation, but on the Math Mountain, I can figure it out whatever I want. So that continues in second grade. Now, the Math Mountain is not a comparison bar. It can solve a comparison bar, but it doesn't represent. Because remember, a comparison bar is a length model. A comparison bar tells us that someone has more and someone has less. That's not what a break-apart model is. A break-apart model means I have 2 parts and a total, right? Or I have a total and a part and I need another part. It doesn't show us that someone has more or less. Now, we can argue, well, of course it shows us because 8 is more and 6 is less. Yeah, but that's not the story that it tells. The story that it tells is something like there's 14 shirts in the laundry. Some were long, some were short. Nothing went away. We didn't lose shirts. We didn't buy shirts. So it's really just about taking a total and breaking it into the different parts. Versus the comparison bar is definitely someone has more, someone has less. We want to know the difference. Okay, so they're not the same, but I could use a Math Mountain to solve it, because if I knew, let's say that this was 14 and this was 8, well, you can see how it kind of looks like a Math Mountain there. So to solve it, yes. To tell the story and to represent it, no. They have different models. So then we get to second grade here, and if you look at second grade continues the work of the Math Mountain, and they really are working on those fact families. I mean, they've been working on them since first grade or kindergarten, but it's really, we pick up the pace there in second. But the second grade now, we're going to use it even more sophisticated, because we can't keep drawing tiny tumblers, right? And we can't count on 17, well, with 1 circle. So it's going to get more sophisticated, because what if I said now that I had 70 and I knew that this number was 40? Actually, let's make it 43, all right? Now I'm looking for this other partner. Well, when students see this on a Math Mountain, as let's say they read a story problem, right, that Joseph collected 70 stamps, 40 of them were his sister's and some were his original collection. How many were his original collection? That's the total, and we broke it into 2 parts. Okay, but again, nothing went away and nothing came. So if I know how to use a Math Mountain, I know that the total always goes at the top. And caution, we don't say the biggest number goes to the top. Okay, because by the time we're finished, we can check our answer to make sure that's true. That, oh yeah, the total is always the largest number at the end of the problem solving. But the problem is that if there were 5 kids came to the pond, and now, let's say, and then we got 3 more, and now we want to know the total, well, they see 5 and they just put it at the top of the Math Mountain, even though that's not the total in that problem. But it's the biggest number, and that really screws us up in the upper grades. Okay, so we're not just grabbing a number, it's the biggest and putting it at the top. We put the total at the top. So when we read that problem, do we know the total is 70? It goes here. The partner goes here. Okay, so now I have the total, now I have the partner. I need to find my other partner, or add-ins. As we get into second grade, we'll start calling them add-ins. So either way, partner and add-in goes hand in hand all the way through 6th grade. So don't let me forget, don't lose me yet. Don't stop watching. I promise you this is going to connect to the upper grades. Okay, so now I can count on, but I'm not counting on by ones anymore. But what I don't want kids to do is this. I do not want to see this. Now, the Math Mountain tells them to do that. The Math Mountain is saying, hey, this is subtraction, because I could do 70 minus 43. But my brain, my reasonableness is like, don't you dare ungroup. What a nightmare to ungroup over here. Can't I just count up? Doesn't the Math Mountain say I can also use it to add? So can't I say, well, 43 plus 2 more gets me to 45, and then I add 5 more and I get to 40, or I'm sorry, 43 go to 45, I add 5 more and I get to 50, and then 70. Now I added 10, 20, 25. Can't I add up 27? So now, do you have to? No, but what I really want is I want students to use the Math Mountain to think about what's reasonable to do. All right, so if you've done any training with me, you know I talk about this a lot, that our kids do not think about what's reasonable. So there's a TEM study, which is an international math and science test that we give internationally, and some of the U.S. 4th graders took it. Of our U.S. 4th graders that took it, they were given this problem, and we had over 80% of our kids miss it. Anyone else like appalled by that? right? But you know they did something like this. They're like, my teacher said never ever do it horizontally, always stack them. And how many of them came up with something like this? Okay? It's because they're not thinking about the relationship of the numbers. They're thinking, oh, subtraction, I better stack them. Addition, I better stack them. Multiplication, I better stack them. I better do an algorithm. No! In what world do we do that? When's the last time you did long division in your real life? Me, never. Okay, I have a calculator now. I use mental math more than anything. I'm looking at reasonableness. So what they should have done is counted back one. Instead, they're double undergrouping over zeros. Either they lined them up wrong, which is what they did here, or they lined it up correctly. Now they have to ungroup over two zeros. Ridiculous. But if you put it on a math mountain and you knew your total was 400 and your partner was 1, you would easily see, oh, the other partner is 399. That's what I want students to see with the math mountain. So I want you to, when you post it, I want you to say, well, what would be reasonable here? How could we solve it? Because it's not just always subtraction or addition. It's, well, use what you want, what makes sense. So then what we have, I'm going to clear this frame, is so that's how second grade and first grade start to use it, is adding up. But now as we get into the older grades, we continue to use the math mountain as that break apart model to look at the reasonable numbers. Now the numbers just get bigger, right? And so now we're just looking at, oh, I know what I'm finding. I can either find the unknown partner, or I can see now that this is subtraction. The model tells us this. Here's what the math mountain does not do. The math mountain is not this. Look at those. What is that? That, my friends, oh, hold on, I lost you. That is multiplication. That is not a math mountain. That is a misunderstanding of the math mountain. The math mountain is two parts equal a total. These have to equal this. This says I have one group of 6 and I have one group of 8, and I am putting them together to get to my total, which should be 14. This does not stand for groups of. So it's not a factor tree. It's not a factor family. Okay, and using it that way is going to really cause students problems of remembering how it's used for addition and subtraction. Since kindergarten, we've been putting these two partners together and bringing them up. We've been pulling them together. Let me just look here. We're putting them together to get our total, like in kindergarten. That's what they're used for. These two parts go together at the top for the total, not equal groups. Okay, equal groups, when we do 48, and we want to know if it's multiplication, we call that equal shares. We say, well, we have 3, 4, 5, 6. So it's like a math mountain, but you just grew legs. Because now I can do 8, 8. I know that how the math mountain works. All those partners go together to get 48. So the math mountain is not a factor tree. It's not used for multiplication or division. The equal shares models and expressions, and that is what it's used. So many programs out there, the ways I was brought up, the way I taught math, or was taught math and taught math for a long time, was with those factor trees. But that's what's important to know. The math mountain or break apart drawing goes all the way through 6th grade, but it is an addition subtraction model only. It is not a multiplication or division model, because it doesn't look that way. A math mountain is a visual model for what I'm naturally supposed to do with it. I am supposed to take this part and put them together. Partner, partner, total. I am not supposed to take this part and do it 8 times to get this. That's 6 times 8. That's 6 groups of 8. A math mountain visually does not show 6 groups of 8. It shows one group of 6 and one group of 8. That equals 14. So I think if you can prevent yourself from having students show you with multiplication division, they're actually going to understand the models better. And when we're using them in our story problems, they'll understand more reasonably what to do with the numbers. In my world, the biggest issue we have is that we have kids that don't know what to do with the numbers. They're guessing. It's like number plucking. Take a number, not going to take a number. We're in a multiplication unit. It's got a 50-50 shot. But they have no idea why they're multiplying them. The model helps us to know what the operation is. And the math mountain is the very first model that we use in expressions, and it's never let go. It's never let go of. We use it all the way through 6th grade. So ask me a question. Let's see. So what are your thoughts on that? So I come over here. So you have the same thing. You did 2000 plus 1 and 2000 minus 1, and they got 2001 but not 90. That's pretty common. So they did not get 1999. That's like what we don't know. Total side note is that when we're in the younger grades, it's really complicated to cross decades. Like count with a kindergartner, first grader, and when they get to 39, watch what happens. They're like, 39, right? It's crossing the decades really hard. Well, we forget that that same skill is really hard in the upper grades. We're just in bigger numbers now. They don't know how to cross the decade into the hundreds, the thousands, the 10,000s, much less go backward. So we're always counting forward and backward. Claire, that's a little bit of a red flag that we don't actually know what happened there. It's actually, that's a numeracy assessment we give kids, is we treat it like an odometer. Like if I go back one or a forward one, what would happen? And it's crossing these decades that is like kids are like, what happened? Okay, so we're going to use proof drawings to help that in expressions. If I have 2,000 and I subtract 1, what would I have to do to one of the thousands blocks? Okay, so ideally you'd have to ungroup it, but there's ways for us to think through that using it with secret code cards. If you built the number 2,000 with secret code cards and we go down one, what places have to change if we subtract one? So great point there. Just a little nugget of information. I think sometimes we do things in the curriculum because we're told to, but we don't actually know why it works that way. And the more we know why, the more committed we are to it. So if there's anything that you're in your unit with, and you're like, I'm not doing that. Like, what is this? This is ridiculous. And usually we think that because we don't understand it, and it doesn't resonate with how we've always taught math or learned math. That's what you should be posting and ask me a question, because I'll tell you, you're right, it doesn't really matter. You can do it like this or this, it doesn't matter. Or I'll say, actually it does, and here's where it's connected at and all the other grade levels, right? So before we just dismiss it of like, it's not important to us, sometimes we have no idea the implications of that over time. And how if second grade, let's say first grade just decides that comparison bars are dumb and they don't do them. Comparison bars go all the way through sixth grade with ratios and proportions and above. They don't go away. And it's not just a math expression thing. Okay, they turn into multiplicative comparisons and then, as I said, ratios and proportions. They're important. So to not do them is like, oh, but they're not important for my grade level. Well, if you think that, then next year's going to have even a harder time using them. So, my friends, my rule always on the Math Mountain is it's partner, total, add and sum. Right? I always have them do like TPR activities, but it's also important that we don't call it different names. It's not the math monster. We don't draw like wigs on him and feet on him. He needs to stay intact so that students recognize him as a whole total. All right. I know it's so hard, like, oh, the biggest number at the top. Well, okay, it's because the big at the end, let's check that. Let's check it. By the time we're done solving, did the biggest number go to the top? Yes. At the end, it's always at the top. But we don't want to make sure they're not grabbing that in the middle. Thanks for adding that. Thank you, my friends, for joining me. I wish you the very best week. Math Genius Squad was supposed to open this last week, so it is coming. If you have people that are still interested in joining, let me know. You can put your name here in the comments, and I will be sure to message you just as soon as it opens its doors. All right, friends. Thanks, everyone. We'll see you guys later. Bye-bye.